There we go. So 1783 is n, 1123 is x, so x over n is p hat, and that should be what they do on the next page. There it is. So that's chapter 8. So what is chapter 9? Well, chapter 9, we're going to bring in the confidence level and the confidence interval. And that's probably right there. Now, I'm going to go to my handy dandy. You can write it down. I'll move this over. Let me get this out of the way. A confidence interval is somewhat of a confidence interval is basically a window, okay? It looks something like this, from 0.58 to p hat to 0.64. That's what it's going to look like. It's going to look like a window that says your lowest value is 0.58 and your upper value is 0.64. That's what a confidence interval looks like. Okay? A confidence level is what gives you the confidence interval. Okay? So if you don't have a confidence level, you don't have a confidence interval. The confidence level dictates the confidence interval. Okay? Now you're going to be dealing with this when future statistics classes. You'll be dealing with a confidence level and a confidence interval, and it's usually when you go into hypothesis testing. Now chapter 10 is hypothesis testing, but we're not going to get that far, so I'm sorry. That's the way the cookie crumbles. Now I could try to press chapter 10 in the next 2-3 days, but I don't think it would be beneficial to you at all if I 2 or 3 days. So we're just going to try to get as far as we can. So hopefully you're finished writing some of that down. Confidence interval for an unknown parameter consists of an interval of numbers based on a point estimate. There's the point estimate, and here's the interval of numbers. And these interval of numbers are based on the confidence level. The 0.58 and the 0.64 is based on the confidence level. The confidence level represents the expected proportion of intervals, these guys up here, that will contain the parameter if a large number of different samples is obtained. The confidence level, or the level of confidence, is denoted 1 minus alpha times 100. Now, before we get started with the estimating and population proportion using the confidence interval and all that, I'm going to tell you to write an index card. And we're going to fill out that index card right now. Now, for right now, you're going to be dealing with a notebook paper, piece of notebook paper, unless you have an index card, and that's great. But we're going to take that index card and we're going to divide it into 4 sections. So let's say this piece of paper is your index card. And this is going to be called confidence level cheat sheet. Confidence level cheat sheet. Now, for the 1 or 2 people that's going to actually do this, it'll save a lot of time on a test or homework. For the rest of you that's not going to do it, don't complain when you have to look up each one of the confidence levels, because I know some of y'all aren't going to do it. So I'm going to just draw a header, and I'm going to divide. I'm limited on my space here, so 1, 2, 3, and 4. And of course, the first is going to be your confidence level. And I'm going to start at 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. Now, the good thing about having an index card is your index card has lines that go across. I don't. So it helps to have those lines because you have everything lined up. And when I draw the lines, they all going to be crooked and look all sloppy. So y'all just have to ignore that part for the 1 or 2 people that's actually doing this. Things I do for y'all. Well, this is something that I come up with a long time ago because I got tired of looking up the dadgum alphas. There we go. So that's what your index card is going to look like. You got your lines going across and everything looks good. Alpha. Alpha is going to be 1 minus your confidence level. Actually, these are supposed to be decimals, but we're going to do, this will be 10, this will be 9, 8, 7, 6, 5, 4, 3, 2, and 1. Technically, let's go ahead and make them decimals because it'll make more sense. And then take alpha over 2. What's half of a dime? A nickel. What's half of 9 cents? 0.045 cent. What's half of 8 cents? 0.04 cent. What's half of 7? 0.035. What's half of 6? 0.03. What's half? 0.025. 0.02. And you see the pattern. 0.015. 0.01. 0.005. Now we have to get the handy dandy calculator out. And I really, let's see, I need to move this over. Technically, these are areas. So I'm going to add a 0 and a 0 on each one. And you're going to use inverse norm. So the first one is going to be second bars, inverse norm, 0.0500, and it's not doing it because I'm stuck in the stupid second. There. Second bars, inverse norm, 0.0500 and paste and enter. That's going to be -1 point, or positive. You use the positive, you don't use the negative. So it's 1.645. And that's your z sub alpha over 2. And you're going to use that in formulas with your confidence interval. So let's go back to second and change the next one to 0.450. 1.695. Second. Change the next one to 0.400. 1.751. And we're going to do every one of these for the 1 or 2 people that's going to do this. Second. And change the next one to 350. -1.812, or 1.812. Second, entering 300. -1 or 1.881. Second. 250. 1.96. Zero, zero. Take it 2.54. $2.17. Oh, me. Thank you. Now I've erased. Oh, shoot. This pisses me off when I have. Sorry. There we go. Finally. $2.326. 2.326. And the last one. $3.29. Now, let me ask you a question. I could have started this index card at, oh, wait a minute, that's wrong. That last one's wrong. I screwed up. Second, 0050, sorry. 2.576. 2.576. Now, I could have started this index card at any number, why did I start at 90% and why did I end at 99? I want somebody to answer those two questions. Why did I start at 90% and why did I end at 99? Why didn't I go to 100? So can anybody answer those two questions? Or try. That means communicate a little bit. Y'all just not going to communicate with me?
I don't have a good guess.
You don't have a good guess. Well, thank you, Miss Stewart, for appreciate that. You know, I hate to tell y'all, but some of y'all are really going to suck at relationships. Okay? Because you don't communicate. That's not good. That's not a good thing. Mr. Passetti, that's not good. And I get nothing. Okay. I don't want anybody to complain about communication in your relationship because you don't communicate in your academic classes. So same thing. So if you complain about communication in your relationship, don't say a word because you don't communicate. And nobody's going to say anything. Why did I pick 90? Why didn't I pick 75 and go up from 75? Or why didn't I pick 80 at 88 and go up? Why did I pick 90? And why didn't I choose 100? Anybody? I got one person that says they have no guess, so that's good. So I've got like, how many other people in the class? I've got 8 other people that have not communicated.
I'm not sure either.
Okay, got 2 people. Okay. So I'm going to take the 2 people.
Either.
Okay. The 3 people I'm going to take that say they don't have a clue. I'm going to say that's for the majority of the people because y'all are not communicating. So I'm going to assume. And that's what happens when you don't communicate. People assume. And that's when people get in trouble. Y'all starting to see a pattern here? Anyway, the reason I started with 90 is because if you're in a job where you are dealing with quality assurance or research or probability, do you want to walk into a director's meeting or a yearly report meeting with less than 90% confidence? That means I want somebody to say yes or no.
No.
No, you don't want to walk into a meeting when you're being paid and you've got to present. You don't want to walk into a meeting below 90% confidence level. Then why did I not put 100? Because nobody's what?
Perfect.
Nobody.
Perfect. Nobody's perfect. And 100% represents what? Perfection. All right. Now, there are some people in this world that believe they are perfect. And if you ever meet one of those people, run as fast as you can in the opposite direction because they have issues. That's why you need to take as many psychology courses as you can. Okay? So this is helpful doing your homework and on the test for chapter 9 because they're going to ask you for this guy right here. Okay? So I'm going to highlight him green because that's who they're going to ask for to plug in to the formula. This column right here is what you want. Now, since the homework and the test is algorithmically generated, sometimes you have an 86% confidence level. Well, what do? Well, let's do an 86 just at the top up here. 86. Now, what's 86 from 100? 0.86. What's 86 cents out of $1? What's left? if you pay for something that costs 86 cents and you give the person $1, what do they give you back?
14 cents.
Thank you. And what's 14 cents divided by 2? 7 cents, Hubert.
7.
And you go, somebody do, well, I'll do it because y'all won't tell me the answer. So I'll just do it. Second, Lars, inverse norm, 0.700. And remember, you take the absolute value. That's going to be 1.476. 1.476. So if they give you an arbitrary confidence level like 86, you just plug it through. 81 minus 0.86 is 0.14. 0.14 divided by 2 is that. And I always tell students to put this in an area form. That means 4 decimal places. And that way you remember inverse norm. Okay? And that gives you your z-score. So this, very important for those 1 or 2 people that did it or that's going to do it. Get you an index card, preferably the large index card, and make sure you transfer this on that index card. It's just like these guys that I told you to do. Saves you a lot of what? Saves you a lot of time. So now let's continue. It says, for example, a 95% confidence level, 0.05, implies that 100 different confidence, blah, 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 blah. Here is the first thing we're going to learn. The margin of error. Write that down. This is your first testable item in 9.1. Margin of error. I call it the MO. Margin of error. And I'm going to go ahead and show you the formula, even though they're going to have it done a different way. Let's see. Where is margin of error? There it is. Your margin of error, don't write anything down yet, is your z-score, so alpha over 2, times the standard deviation, which is the square root of p hat q hat over n. This is the margin of error formula. So write that down, margin of error formula. And please make a note that MO stands for margin of error. If you go into the research fields or a research class, some people will call the margin of error MO. Sometimes it's referred to as a big E. So sometimes margin of error will be MO. Sometimes somebody will refer to it as E. So make sure you make a note of that. You're going to add and subtract the margin of error, just like you did the standard deviation. Just like the standard deviation in Unit 1, you will add on the right and subtract on the what? Left. And we'll get to that in just a minute. So there is your z sub alpha over 2 that I told you were going to be using. And look at there. That's what we learned in chapter 8. So I'm going to take my pink highlighter. I got new highlighters. And there, we learned that in chapter 8. So there is nothing new to you because you've got an index card with z sub alpha over 2. And you learned how to find p hat, q hat, and n is the biggest number in chapter 8. So let's look at the problem they give us. If it's a decent problem, let's look and see. Now, I will tell you this. These two things is what you're going to be tested on in chapter 9. Level of confidence, confidence interval, and sample size. So, and margin of error, that's, but these are two more things that you're going to, so you don't have to, but sample size is the last thing we're going to learn. Anyway. And remember, these are the things that we learned in chapter 8. The two tests, NPQ has to be greater than 10, and little n has to be less than 5% of big N. I'm trying to find an actual question, so if you're wondering why I'm kind of skipping around, I'm trying to find an actual question. Here we go. All right. It says in July of 2008, a Quinnipiac University poll asked 1783 voters whether they opposed the death penalty. 1123 were in favor. Well, that wouldn't go by now. As crazy as our society is getting, that would be reversed. I'm just saying, our society right now is opposite 10 years ago, not to mention 20 years ago. Obtain a ding 90% confidence level, 90% confidence interval, sorry. Okay, that tells me that sentence right there, highlight it, refers to that 90% confidence level right there. So I need you, when you're writing down this question, because this is a test question, this is what I would ask you out of chapter 9. It says obtain a 90% confidence interval for the portion of registered node, blah, 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 blah. This right here, I want you to highlight 90% confidence interval. That when you highlight that, then I want you to go to your index card and highlight that 90 right here. Sorry. That 90 right there. Because that 90% confidence level refers to this z-score right here. Okay? So we're going to be using a z-score of 1.645 in this calculation. And see, if I can take that part out of your calculation, the go and looking for and trying to find these z-scores, if I could take that out of the calculation, it will make life easier for you. You're welcome. So 90% confidence level, we're going to use that z-score of 1.645. Well, p hat, so I'm going to write all this stuff down. Let me go to my handy dandy sheet here. And I'm going to write this stuff down. Okay. N is equal to 1783. X is equal to 1123. And you want a 90% confidence level. That's it. So what can you do first? Well, you got P hat, you got to get first. P hat is equal to 1123 divided by 1783. Take your handy dandy calculator and take 1123 divided by 1783. And that's 0.63. I'm going to take it to 4 digits. 0.6298. Minus 1. 0.3702 is Q hat. 0.3702 is Q hat. And we've got N, and we've got the 90% confidence level. So we're good to go. Because what do we need for our formula? Let's go back and look at the formula. There's the formula. So I'm going to take my handy dandy yellow highlighter, and I'm going to highlight what we have versus what we need. Well, there's Z. We've got the Z score. I'm going to take my handy dandy index card. There's our Z score. So I'm going to take that. Z sub alpha over 2 is equal to 1.645. And I'm going to draw a line right here with an arrow via index card. That 1 or 2 people actually do. Okay? So let's highlight what we have. Z, we got it. P hat, we've got it. Q hat, we've got it. And N. Well, looks like to me we got what we need. So that means I'm going to plug and chug. So my MOE, or my margin of error, is equal to 1.645 times the square root of 0.6298 times 0.3702 divided by 1783. So now I'm going to take my handy dandy calculator out and do it. .6298 times 0.3702 divided by 1783 and raise that to the 0.5 power. Okay, so that's going to be, and multiply that by 1.645. You got a 2% margin of error. So the margin of error is equal to 0.0188109083. Now, I can tell you right now that most margin of errors are going to be rounded to the second digit because it's a percentage. Margin of error is usually a percentage. And you can write that down on your sheet right here. Usually a percentage. Therefore, 2 decimal points. Usually. Okay. Sometimes 3 because they want a, 0.5 or, something like that. So sometimes 3 decimal points because they'd like to see 2.5 or 12.5. They like to see that 0.5 or whatever. So, or 12.4 or whatever. So depends on the directions, but usually it's going to be 2 or 3 decimal points because the margin of error is usually a percentage. So with that being said, I'm going to just round this to 2 decimal places, and that would be 0.02 or 2%. So you have a 2% margin of error. Is that important in statistics? Hell to the yeah. Anything more than 3 is worthless. You would not walk into a director's or a yearly report if you're being paid umpteen dollars a year. You wouldn't walk in with a 5% margin of error. You better go back and do some more work. 2% is good. The lower, the better. The higher, you're not doing your job. Okay. Now, how do you set up your confidence interval? Well, remember I told you it's like the standard deviation. This guy right here is what you're going to use. That's kind of like your mean, and this is your standard deviation. Okay, so I'm going to round this to 0.63 because I'm not going to add all those decimals. So I'm going to round that to 0.63. So P is in the middle. What is 0.63? What is 63 cents minus 2 cents? 61. What is 63 cents plus 2 cents? 65. So this is your confidence interval based on a 90% confidence level. This is your confidence interval. And that is a test question. Okay? This is the whole question right here. What's given? Everything up here, right here, is given. That right there is given. The rest you have to do. You start off with getting P hat. P hat gives you Q hat. This confidence level, go to the index card, gives you your Z. At that point, you have everything you need to do the problem. So this is our third section. You're going to get 2 or 3 test questions on 8.1, 2 or 3 test questions on 8.2. You're going to get 2 or 3 of these. And you're going to get 2 or 3 of the finding sample space. Okay. Now, that's all for today. Let's see how far we got. Let's see if they got the right answer. 0.61 and 0.65. Look at there. That's what we got. It's a miracle. I'm looking to see. Okay, that's the second type question of 9.1 right there. And we'll get to that. We'll get to the sample size. We'll get to that. Let's see, what's today? Friday, or today's Wednesday. We'll get to this Friday. And chances are that's probably as far as we're going to go. I don't know if I'm going to go. I don't know. Let's see. Am I going to go to? Probably not. No, I'm probably not going to get to 9.2. So Friday is probably going to be our last day of new material. And then Monday, we'll see if y'all got any questions, send them from homework, and look at the test on Monday. That'd be a good last day. What do y'all think? Did anybody new show up, or anybody else show up? Let me look at the attendance right quick. Turn off the recorder. Let me look at the attendance right quick and make sure nobody else showed up. Okay, Jermaine and Loftus.